Sathyabama Institute of Science and Technology.
Myself Karthik, Assistant Professor in Mathematics from Sathyabama Institute of Science and Technology, Chennai. So today we are going to look at the topic bivariate data. In that particularly we have correlation and regression. Let's see the definition of correlation. Correlation is nothing but the relation between two variables. So one is dependent and another is independent. So here let's take the dependent variable as y and the independent variable as x. So based on this we are going to look at the three things, which is nothing but the correlation varies from -1 to +1 when there is no correlation, which is equal to 0. +1. So +1 is nothing but the perfect correlation. So there both variables move together. Just like if the independent variable increases, the dependent variable also will be increased. In -1, which is nothing but the perfect negative correlation, which is nothing but which is in the opposite sign. When independent variable increased, then the dependent variable will be decreased. And no correlation, there is nothing between that, there is no relationship between independent and dependent. So the relation is nothing, that's why the correlation is 0. Okay, so here we have several types of data. So let's see, the data will be less than 20 and more than 20. If the data will be less than 20 means we just use this formula, which is nothing but just take the given data of independent and dependent variable as it is of x and y. If the data are more than 20 means we can take it as by using x minus x bar for reducing the terms in independent as well as dependent. So this is the formula, r equal to n into summation xy minus summation x summation y divided by root of n into summation x square minus summation x the whole square into root of n into summation y square minus summation y the whole square. This is for when the values are less than 20. For example, the first values of x is 12, another is 8, 11 and so on. Similarly in y also. If the data in x and y are more than 20 means, for example, x equal to 25, 100, 190 and so on, we have the data are like that means it will be difficult to calculate to apply the x squares and x into y and the remaining things also. To avoid those things, we are going to use a deviation by using the formula dx equal to x minus x bar and dy equal to y minus y bar. We know that what is x bar and y bar, which is nothing but the mean of x and y. So x bar summation x by the number of terms, y bar summation y by the number of terms. Let's see a problem in that. So here we have a question. So let it be x and y as it is directly without mentioning what it is. So x, y both are less than 20s, which is nothing but 12, 9, 8. These are all the values which is less than 20. Similarly in y also. So that we are going to use the formula summation x as it is x, y as it is y. And let's see the table. X what they have given, y what they have given, then x square, y square, xy. X square, just square the values of x, apply the terms. 12 square is 144, 9 square is 81 and so on the remaining in x, as well as y. 14 square 196, 8 square 64 and so on the remaining also. Finally x into y, 12 into 14, 168. Once we have done this, you just add all the data together and apply the total here, just like this. Then we have the totals here, then substitute the data into the formula. This is the formula when we have the data are less than 20. So we just substitute the values. Here n is nothing but the number of terms, which is nothing but 7 here, and the values which we have calculated you just substitute here, so that we have the calculation just like this. After that the result will become 0.95. As I told already, the correlation value lies between -1 to +1. Here we have 0.95, which is a positive value, so that we can say that which is a positive correlation. So this is an example for we have for more than 20. So here in x all the data are less than 20, but in y we have the data are more than 20. So it is eligible for both using without deviation and with deviation. So I just like to use with deviation only, just like dx is x minus x bar, dy is y minus y bar. So that take x as it is, y as it is, then we can see that x and y is here. Take total of the x and y, then find mean of x and y. which is nothing but 140 divided by number of terms is 10, it is 14. Here 580 by 10, 58. So dx will be x minus 14, dy will be y minus 58, and we have the calculation here. Once we have subtracted from every value is in x, every value is in y, and now we have the data of dx and dy. From this only we are going to find dx square, dy square and dx into dy. Along with the data, take the summation of all these data, then substitute the data into the formula. Here we have the Karl-Pearson's formula, which is for more than 20. Substitute the data which we found already, just like this. So after this, the calculation will become, and the R value is 0.79. This is also a positive correlation. Under correlation, we have another model which is nothing but Spearman's rank correlation. Here we have seen some data already, which is nothing but there is a relation between x as well as y. After that, we are going to look at using rank. So that is nothing but some data will be already ranked, some will be not ranked, and some data will be repeated. So for all these three things, we are going to look at the topic in Spearman's rank correlation. So let's see the first one, ranks not repeated. When the ranks not repeated means, we're going to use the formula rho equal to 1 minus 6 into summation d square divided by n into n square minus 1. Here d is nothing but we have independent and dependent, right? For those things, either the rank already given or we need to find the rank. However, let the rank of the first one is R1, another one is R2. We need to find the deviations. So R1 minus R2. After that, we're going to square the value of d. So that we're going to find summation d square. This is for rank not repeated. If the rank is repeated, rho equal to, we have the formula this one. So here 1 minus 6 summation d square plus 1 by 12 of m1 cube minus m1 plus m2 cube minus m2 plus m3 cube minus m3, etc. and so on. This is only for the m1, m2, m3s are nothing but when the rank is repeated, which rank is repeated and how many times is equal to the first m1. And the next m2 is nothing but the another rank which one is repeated, that's one we're going to apply. Similarly and so on the remaining terms, how many times it has been repeated. Let's see some problem on this. First one, here the data we have x and y. Here we are going to use a Spearman's rank correlation and they didn't give the rank for the data. We need to identify the rank for this. So first of all, check the data are repeated or not repeated. So here the data are not repeated. So we're going to use the not repeated formula, which is nothing but 1 minus this one. Then we are going to give rank for this. Let x as it is, y as it is, and then rank of x, rank of y. Rank of x is nothing but in x we have around 8 data. From this, choose the highest value, which is nothing but 73 is the highest one. Give rank 1 for the highest one. Then what is the next highest is nothing but 68, rank 2. Then 65, rank 3, and so on up to the 8 terms you need to give rank based on their values. Similarly in y also, 74 having rank 1 and then 72 having rank 2 and so on the remaining up to the 10 terms. Here we have R1 and R2, which is nothing but rank of x and y. We are going to find the deviation from that, either R1 minus R2 or R2 minus R1, both are accepted. So d we have this one. However, we are going to square the term. So d will be squared. So d square we have, take the summation for d square. So summation d square is equal to 26 now. Then the calculation will be, substitute the data into the formula 1 minus n value 6, summation d square becomes 26 and substitute the values. Then we have the calculation rho equal to 0.78, which is also a positive correlation, then the conclusion for that. So here we have the data which is repeated. So here x having some repeated values as well as y having some repeated values. So when the values are repeated, obviously it's under Spearman's rank correlation, so that the formula will be along with m1, m2 and so on. The calculation will be whatever the data, as usual you just apply as same x, y. Then we are going to give rank for that. Here it is the most important thing you need to notice that when the rank is repeated, you just allocate all the terms in order. So here we have 8 values, you just apply all the 8 values in decreasing order. Then give the rank for that. For example, here we have 85 is the highest value, give rank 1. Then 82 is the next highest, give rank 2. Then 75 is the next highest, give rank 3. Then 73, give rank 4. After that we have 3 consecutive values which is repeated as same 68, 68, 68, which will be occupy the places of 5th rank, 6th rank and 7th rank. But the values are same, we can't give the 3 ranks as different. So we need to give the 3 ranks as same. So what are the 3 values consuming the particular ranks? You just add all the 3 ranks, that's nothing but 5th rank plus 6th rank plus 7th ranks, that's nothing but 5 plus 6 plus 7. The result will be 18 divided by 3, the result will be 6. So 6 is the common rank for 68, 68 and 68, that's what we have applied, 6, 6, 6 here. Then the remaining places are only one 8th place, that's nothing but 61 having the 8th rank. Similarly in Y also, first rank, second rank up to the remaining, you're gonna apply the same in the decreasing order. Here we have 71 which is in the 3rd place, 71 which is in the 4th place. When the values are same, you should give the ranks also as same. So that's nothing but 3rd rank plus 4th rank, 3 plus 4 by 2 which is equal to 3.5. So 3.5, 3.5 having the same places for 71. So now we have calculated R1 as well as R2. After that we know what to do, find the deviations R1 minus R2 or R2 minus R1, both are okay. So D we have found. Then obviously we are going to square the terms, D square, so 1 and so on. Take the summation for this, we have 18.5 which is the sum of the deviation square. Then the formula as usual already we have discussed. Here in this we need to notice that what is M1. M1 is nothing but 3, just because in X we have 68 3 times, 68, 68, 68. So 3 times it has been repeated, so M1 equal to 3. In Y we have 3.5 in 2 times, so M2 equal to 2. So these are the 2 repeated ranks we have. So that the calculation we are going to substitute M1 as 3, so 3 cube minus 3, M2 as 2, so 2 cube minus 2, and after that the calculations overdone. We have the conclusion, that's nothing but rho equal to 1 minus 6 into 21 by 8 into 63. That will give the conclusion as a simplified result, rho equal to 0.75, which is also a positive correlation here. Then along with this, the most important topic in correlation, when they have given more than 2 datas. So obviously correlation is based on 2 variables only. So if they have given more than 2, you should take as a pair. Here for example, there they have given 3 datas. So the datas is nothing but some judgment results based on a beauty contest. So here judge 1, judge 2, judge 3, they have given ranks. So we don't need to identify the ranks, it's already given. So when they have given these things, the question they have arised is, it's nothing but whose taste is similar. So that's nothing but we need to identify based on first judge and second judge as a pair, second and third as another pair, and first and third as another pair. So for these 3 we are going to find from the 3 different rank correlation. The correlation varies from -1 to +1. When the value approaches the +1, that pair only we are going to take as a best result. Here we have that, and the formula is also similarly same, there is no change on that. Let's see the calculation. So look at the table for the judge 1, judge 2, judge 3, you can take X, Y, Z also, that's not a problem. So we need to find the rank already given as I told. So find D1, so deviation of first and second, D2 deviation of second and third, and D3 deviation of first and third. So D1 you know what to do, subtract from one to another, D2 also same, D3 also same. Once you have done this, then square all these 3 again, D1 square, D2 square and D3 square. Once you have done this, take summation for all these 3, summation D1 square, summation D2 square and summation D3 square. After that we are going to substitute this and the third one alone to the same formula, just like this. Look at here. So here we have 3 rank correlations. So I just apply row 1, row 2, row 3. Using that the same formula, just a small change, D1, D2, D3 and it squares. Then substitute the datas, so that we are going to get the values after the calculation is row 1 equal to 1 minus this one, row 2 and row 3, and finally we have the result. Row 1 is in negative term, row 2 is in negative term, Row 3 is positive term. Sometimes you have all of them as positive. No need to worry for that. Which value is closer to plus 1? If all the values are positive terms, which is highest? So based on that only we are going to consider that particular result is the best one comparing with the previous. So here row 3 having 0.64, which is best than the previous two, row 1 and row 2. So row 3 is calculated based on judge 1 and judge 3, right? So that the result will be the judges 1 and 3 are the best pair ranking the beauty contest. Okay, so this is a value for the 3 judges problem. So along with this, we just wind up this session. So the next topic, regression, will be taken in the next class. So thank you all.